Hello everyone, in this video I'm going to be talking about how you can test for anions. Now anions are negatively charged ions, we'll just put that by the title. And this is one of two videos that I'm doing looking at how you test for these particular ions in an unknown sample. It's part of what we call qualitative analysis in inorganic chemistry. So qualitative because we're not getting any quantities, any values, we're just trying to identify which anion we have present. So I've done one video already on testing for cations, and this video is all about how you can test samples for these unknown negatively charged ions. So again, I'm going to maybe shrink the screen at various points to fit all this in, but what we're going to do is we're going to have our sample X, our unknown sample. I'm going to start by writing this at the top. So now what we need to do is to add some dilute hydrochloric acid to the solid and warm gently. So when we're going to test for particular anions or negatively charged ions, what we need to do is, and I'll just make a note of that there, add dilute HCl to our solid sample and warm that gently. Now, like I've done in the other video, I'll put the different questions we need to ask. So the question we need to ask this time is a gas given off when we do this? Now, if the answer is yes, or if the answer is no, we go down two different paths. So first of all, what I'm going to do is go down the yes path. I'm going to say that this gas is given off. So if it is, we've possibly got sulfur dioxide, carbon dioxide, or maybe hydrogen sulfide. So let's consider our options. If there is a rotten egg smell, now this is a classic unmistakable smell. If we've got a rotten egg smell coming from that reaction of our sample X with adding dilute HCl, then we definitely have the S2 minus, the sulfide ion present. Now if, however, instead of that rotten egg smell, if potassium dichromate when added, we'll just put add potassium dichromate. If that were to change colour, if that were to go from orange to green, then what we would have identified is the SO3 2 minus ion, which is the sulfite ion. So that would be present. But if it's neither of those, as I said, we may have got carbon dioxide given off. So we need to do a lime water test. So if, in amongst those two, if instead lime water goes cloudy, then we've most likely got CO2 as the gas being given off. And what we can say is that we've identified that our unknown solid, our unknown sample X, has the CO3 2 minus anion present, which is the carbonate ion. So there we've been able to identify the sulfide ion, the sulfite ion, and the carbonate ion. If, when this gas was given off, if indeed it was, when we've added sample X to some dilute HCl and warmed that sample slightly. But what happens if the gas wasn't given off? So we're going to look at the other side now. If, after this first question, if no gas was given off, then that leaves us another route we've got to follow. So what we need to do then is we'll add 3 drops of what's called barium chloride to the solution. So what we're going to do is add 3 drops of barium chloride to the solution. Now, what we need to look for, again, here's another question, is do we have a white precipitate? So we're looking for a white precipitate. If the answer is yes, if we do indeed get a white precipitate when we've added 3 drops of barium chloride, then we've identified what's called the SO4 2- anion, or the sulfate anion. So we found SO4 2-, which is the sulfate anion. But if the answer was no, if we didn't get a white precipitate, then what we need to do is take some fresh solution and add an equal volume of dilute nitric acid. So if we didn't get a white precipitate, we need to take fresh solution, apologies if my writing's a little unclear here, and add an equal, and that's key to this, an equal volume, and I'll put a deal for dilute nitric acid. And at this point I'm just going to reduce the size of the screen overall, just so we can make this flowchart a little bit bigger. In fact, I think I might bring this over to here just to give us a little bit more room. Now, once we've added an equal volume of dilute nitric acid, we then need to add 3 drops of silver nitrate solution. So we're going to plus 3 drops of silver nitrate solution. And then we look for whether we've got a precipitate. So again, we need to question, do we have a precipitate forming? That's what we're looking for. That's what we need to assess. Now, if we don't, then again, we've got to follow another set path. So what I'm going to do here is follow the no path first of all. So let's say that we've added that and there's no precipitate forming. So what we then need to do is add a few crystals of iron 2 sulfate to some fresh solution. We need to heat gently to dissolve and then slowly drip concentrated sulfuric acid into the tube. So I'll just make a note of that because there's quite a few things there. We're going to add a few crystals of iron 2 sulfate. We're going to then heat gently to dissolve, and then we're going to drip concentrated, and that's key here, concentrated H2SO4 sulfuric acid into the tube. And we need to look to see whether we get a brown ring forming. So we're looking for, this time, the presence of a brown ring forming. If we don't, then what we've got is an unknown anion, because at that point we should have done some definitive qualitative analysis. So at that point we've got an unknown anion there. But if a brown ring is formed, if we do get a brown ring forming, then what we've got at that point is something called the NO3-, the nitrate ion. So if the answer to that is yes, if we do get a brown ring forming, then what we've got is the NO3- or nitrate ion. Now let's go back down. So I said if we add 3 drops of silver nitrate solution, if we don't get a precipitate, then we have to go through this and look for a brown ring. Let's imagine that we do. Let's imagine that we did get a precipitate. So we're going to follow now the yes path and see which anions we can identify from this route. So this is now yes, if we did get a precipitate. So if we did, we need to now add ammonia solution until it's in excess. So at this point, we need to add ammonia solution until it's in what we call excess. So until we've got essentially too much of it. Now, then we can have really three different options. If we get a white precipitate which dissolves, then we've identified the Cl- anion, which is chloride. So we've got three possible options here. So if we get a white, I'll colour this in, a white precipitate, which dissolves, then essentially what we've identified is Cl-, and that's the chloride anion. If though, when we add ammonia solution until excess, we've got an insoluble yellow precipitate, so if instead we end up with an insoluble yellow precipitate, what we've been able to identify there is the I- anion, and that's the iodide ion, which leaves us one option, and that's if we get a slightly soluble cream precipitate. So if we get a slightly soluble, I'll just reduce the screen ever so slightly to just fit this a little bit in here. If we get a slightly soluble cream precipitate, then what we will have found is the Br-, or the bromide anion. So there we go. A few simple investigative techniques we can use to successfully identify which anion we have present in our sample X. And you can see there's quite a variety that we're able to get here. We can identify whether we've got sulfide, or sulfite, or a carbonate. We can work out if we've got a sulfate, a nitrate, a bromide, an iodide, and a chloride. So a whole variety of anions there that we can test for. Okay, hope all that helps.